I will say three things. First of all, you've been a friend of Preventable Surprise and an advisor for a long time. You worked with our founder, Rashtam Theorem, particularly on framing the systemic challenges of climate for the investment sector. You've been a director at SG Warburg. You've been European chief executive at the U.S. Investment Bank, Wasserstein Perella. You were a founder and chief executive of New Star Asset Management, a trustee of the Science Museum in London, chair of the Isaac Newton Institute for Mathematical Science at Cambridge University, the founding chair of UK's Alan Turing Institute, which focuses on big data and artificial intelligence, and the chair of Clients Earth, of which a few representatives are on the call today, which is a leading public interest environmental law firm. I'm done. Howard, welcome.
Jerome, thank you very much for running through that list. And everybody, it's a great pleasure to be here. I'm going to talk to you about life in the early Anthropocene. So let me share my screen and we can get going with that. Here we are. Okay. I take it you can all see that. Yep, good. I'm just minimizing. There we are. Good. So the Anthropocene. The Anthropocene is, as I've said in my footnote there, an unofficial geological epoch. The geologists haven't formally decided on when it began yet. I think it began around 1950, and it is marked by the significant human impact on the planet's geology and ecosystems. So let's have a look at the early Anthropocene. So two key actors in the early Anthropocene, before we get around to the geology, are artificial intelligence and China. And I just want to talk very quickly about those. For those of you who haven't kept up with the history of artificial intelligence, there's a little table on the left. So in the 30 years from 1980 onwards, the three great platforms, PCs, the internet and the iPhone, were developed. And then in the last decade, artificial intelligence came of age. It began with pattern recognition. This is face recognition. It's the ability of algorithms to understand, or rather to recognize spoken words. That became clear in 2012. It became commercially doable in 2012. By about 2015, the ability to recognize patterns was already up at human level. Something very special happened in 2016. DeepMind, a subsidiary of Google, invented AlphaGo, which defeated one of the world's Go champions at the game of Go. This was about 10 years ahead of where the industry expected such a feat. And it was remarkable because AlphaGo played with great originality and what some would call insight if it were a human player. And it really made people sit up. One little corner of AI, which has been developing very rapidly since then, is what's illustrated in the rest of the table. This is what's happening with natural language processing algorithms. These are algorithms which examine sentences and learn, they teach themselves to forecast what will come in the second half of a sentence from the first half of a sentence, and to locate the keywords in a sentence. And the way they teach themselves is they come equipped with lots of parameters, and they tune the values of those parameters by looking at billions of sentences, the whole of Wikipedia, every English language digitized sentence available on the web, for example. And I've put there the run of parameters. You can see that in 2018, a Google system had 350 million parameters. If you drop down the table, a Chinese system called Wudao2 last year had 1.7 trillion parameters. The number of parameters is growing at something like 10 times a year. Now, there isn't a straightforward relationship between parameters and ability, but surely when you increase the parameters, you do get an increase in what these programs can do. What they can do right now is they can hold conversations. They can write essays, they can write sports commentary, they can write poetry. Wu Dao too can write poetry in Mandarin and in English, perhaps as you'd expect. And right at the bottom of the table, I have put the number of synapses in the human cortex, 125 trillion, and you can see the number of parameters is rapidly approaching the number of synapses and will be there in 2 or 3 years' time. It's deeply interesting that natural language processing is making such rapid strides. The thing that I find intriguing about it is its immediate application to the metaverse. I mean, this is something which is being set up. You will have an avatar in the metaverse or even a hologram in the metaverse, and your avatar will interact with other avatars. Behind them, there may be humans, but as these natural language processing programs develop, there may be AIs behind avatars. And the kind of interactions that will go on in the metaverse will give AI algorithms a sort of first-hand opportunity to interact with humans and understand how language is used in a very fresh way. That's all very interesting. Let's just see how China has been using this. I've put in that green box China's tech journey. It's their tech journey through the last decade. It starts with Tencent's WeChat super app, launched in 2011. You can access just about every digital service through WeChat. Xi becomes president. The Sharp Eyes rural surveillance program began. That was to extend the urban surveillance program. There are now something like 1 billion surveillance cameras in China. And of course, they're being monitored by AI algorithms, among other things. In 2014, the social credit plan was launched. If you do good things, your credit score goes up and you can access high-class services. If you do bad things, it goes down and you can't. And what you do online is a major input into your social credit score. 2015, a biometric database for every Chinese person to have a record in began. Made in China 2025. This was the Chinese program to make sure they could dominate all major industries of importance to them. 2015, China flipped to mobile payments within 18 months. There's a picture on top right of a very happy beggar begging with a QR code. The reason that works is because the transaction charge is 0 for small transactions. Then in 2016, DeepMind's AlphaGo that I've already talked about, this was an epiphany for China. The Chinese were absolutely amazed that a West could write an algorithm that could play their game so well. And it was followed a year later by China's national AI plan for leadership in AI by 2030. 2020, the digital renminbi was introduced. This gives the Bank of China direct access, or rather oversight, to individuals' transactions throughout the economy. And the complementary cryptocurrency ban was brought in the following year. And in that year, in 2021, there was a range of tech company restrictions. Tech is so important, it can't be used in China to establish rival centers of power. It's something which has to be controlled by the government. There's a couple of footnotes, really. You will have read that in 2021, China made great progress with hypersonic missiles and started upping its nuclear missile fleet. You get the picture of China being very, very advanced in technology, using AI to monitor and control its people, and being able to defend its sphere of influence, whatever that is. And then just another footnote, really, those are not the only technologies that China is doing very well in. Quantum technology is coming along rapidly, and in 2 or 3 of the sectors of quantum technology, China is a clear leader. And finally, I conclude with Wu Dao 2, the natural language processing algorithm, just to show that at the moment China is in the lead in that little sector. The bottom picture on the right is a couple of police officers. They're not wearing sunglasses, they're wearing face recognition glasses. Their handheld devices have the prison records or the profile, perhaps, of the person that they are looking at. So they can monitor and control out on the street pretty easily. So there's two key actors. Let's just get on to the geology. I think it's abundantly clear that a geological transition is underway. And let me take you through this, starting at 12 o'clock, starting with the atmosphere. It's currently warming at about 1/4 degree centigrade a decade, precisely as climate scientists have been predicting for the last 30 or 40 years. What is startling them and everybody else is the impacts of this warming are greater than expected, and they are coming much sooner. Of course, a big effort is being made to cut down that 1/4 degree per decade, and we will see how far we get with that. On nature, there are about 3 trillion trees now. There used to be 6 trillion. The trees are about half gone. They're going at around 2 to 4% a decade at the moment. That doesn't sound very much, but some big forests are at a tipping point, and I'll come to that in a moment. Nextly, biodiversity. Wild terrestrial animal biomass is decreasing at something like 10 to 20% per decade. You can do the arithmetic on that. It's not very difficult. There will not be much left if we continue at that rate. And it's interesting that both mammals and insects are declining at that kind of rate, depending on where you look. And you might ask yourself, what is it we're doing with the insects? And there's a little box that says what we're doing. It's habitat disruption and fragmentation, urbanization, deforestation, agricultural conversion, nitrification, pesticides, climate change, introduced species, light pollution. We are creating a toxic environment for non-human life. It is in many ways a remarkable achievement to be able to do that. There are tipping points coming. There's a cascade of tipping points. The urgent ones, if I can put it that way, are the Gulf Stream, which carries heat up the Atlantic from the equator to the Arctic. It looks like the Gulf Stream is on the cusp of stopping. What being on the cusp means is anybody's guess, and how long it will take to stop is also anybody's guess. But it may stop sometime in the next few decades, completely altering the weather patterns, not only in the north, but down by the equator. The Amazon is about 20% gone. It's not clear where this becomes fatal to the Amazon rainforest. It's somewhere probably between 20% and 30% destruction would flip it into savanna. That would completely, apart from the loss of biodiversity, it would flip the weather systems in Brazil. The boreal forests, the northern forests, may be approaching a tipping point where instead of being net sinks of carbon, they become net sources. This is because they are drying out, being attacked by insects and burning. Permafrost is melting, and there's a potential tipping point where large amounts of methane are released. And again, in the news quite recently, West Antarctic glaciers look as if they are beginning to crack up. The two big West Antarctic glaciers are like corks in a wine bottle, and if they do crack up and disappear, the large ice sheets will be enabled to slide off the Western Antarctic. The West Antarctic contains about 3 meters of sea level rise equivalent. Quite how fast that will hit the sea is anybody's guess. There are more, but I'll stop there. Just going around farming, we're losing topsoil at about 10% per decade. Farming will be a historical curiosity by the end of this century. Migration. Humans like living in a niche of average annual temperature of about 11 to 15 degrees centigrade. Within 50 years, 10% to 30% of humanity will be outside of that niche, which indicates potential migration up at the order of 1 billion people or more. 2 more to go in case you're not feeling sufficiently depressed. Human fertility is falling at something like 10% per decade. By human fertility, I actually mean human male sperm counts are falling at 10% per decade. This is due to chemicals called endocrine disruptors in the environment. Endocrine disruptors leach out of certain sorts of plastics in the environment. You can lose sperm at quite a high rate for quite a long time because all males produce a lot of them, but there will become a tipping point, maybe in 30 or 40 years' time, where fertilization may become difficult. And then finally, the oceans, they have been warming at about 0.13 degrees centigrade per decade. We've done about 1 degree of warming so far in the last 100 years. The acidity is increasing by about 10%, acidity measured as the number of hydrogen ions, 10% per decade. And sea level is forecast variously sea level is forecast to rise at something like 0.5 meter to maybe 2.5 meters this century. And I've just made a note over on the right about oceans. 80% of animal biomass lives in the seas, and 30% of fish grow up in coral reefs now being eliminated. And of course, we're creating dead zones and polluting oceans with plastic and overfishing and threatening to mine the seabed. We are doing an awful lot to change the oceans very quickly. The geological transition is underway. I mean, clearly from what I've said, it's being accompanied by a very large extinction event. Quite how large, I think it's very, very hard to say. What happens historically when there's a geological transition and an extinction event is new species arise, and somewhat provocatively, I have put over on the left my idea of a new species. It's artificial intelligence. I don't mean it in the sense of killer robots, as the picture would suggest. I do mean it in the sense of AI algorithms, which are being used more and more to monitor and control the media, and the metaverse, and services, transactions, drones, surveillance drones, power grids, and ultimately weapons. As these things get more sophisticated and as the world becomes more turbulent, it is not inconceivable that, that AI will be created which misaligns with human interests. And that's one of the things that worries a lot of AI researchers. This all points, in my view, to the possibility of a deep global disruption sometime in the early Anthropocene. By which I guess I mean sometime this century. What do I mean by deep global disruption? Well, I've put a picture on the top right of a lake. That is Lake Toba in Sumatra. 75,000 years ago, it was a supervolcano which erupted and spewed 3,000 cubic kilometers of material up into the air. The presence of all that material in the atmosphere caused a volcanic winter. The atmosphere darkened, the temperature dropped by about 4 degrees centigrade, and those conditions remained for about a decade. One can imagine what would happen if nowadays, if that happened, given our economic development. What you might guess is that maybe half the world economy would halve in size or something like that. You might get a 25%, shall we say, reduction in output. That's the kind of thing I mean by deep global disruption, a 25% reduction in output lasting for some reasonable time. How could you get that? Well, I've put half a dozen possible things that might cause that. To estimate the probabilities of these things, I have relied on studies at a number of institutions of existential risk, the risk that humans might eliminate themselves. And I've tried to work from these estimates of probability to deep disruption risk. There's a footnote if any of you want to follow that up. So the estimates of existential risk and what I'm taking as deep disruption risk from misaligned AI is 1 in 10 per century. This means if you simulated the world and ran the simulation 10 times, 1 time out of 10, there would be a real problem for misaligned AI, and the world would have to stop and de-digitize for a while to sort out the problem. I reckon that the risk from climate change this century, from extreme events causing such problems for societies and possibly the economy that it can't cope, is also 1 in 10 per century, the same as misaligned AI. Other lower risks, but still significant: engineered pandemic. This is a nutcase or a terrorist using biotech, which is now very easily available, to modify a virus in the garage and make it much more transmissible, much more deadly. The existential risk experts' view of the engineered pandemic risk is about 1 in 30. That sounds reasonable to me. The risk of nature destruction, the value of the services provided by nature are roughly the same scale as world output, and we are reducing those services quite rapidly. I've put the risk there at the same as the engineered pandemic. Nuclear war, I've just put in the same category of risk without really stopping to think any further. And then the risk from all further new technologies coming this century, again, I've put in the same bucket of 1 in 30. Now, you can argue with each of those risks, of course, and you could make them higher or lower, but I suspect you couldn't make them very, very much lower. If you ask yourself the question, given all of those risks, and if each of them is independent, what is the total risk of at least one event? So that would be the total disruption this century. It's about 1 in 4. That's an interestingly large number, 1 in 4. And 2 things to mention about it. The risk of a supervolcano is about 1 in 1,000 per century compared to the 1 in 4 per century. So we're running risks now which are much, much higher than the risks from nature that we're used to. And secondly, our great Prime Minister said at the opening of COP26 that if we don't sort out the climate problem, a decline in civilization is possible, which is what inspired me to do this calculation. I think he's dead right. I think if you equate a 25% reduction in global output with a decline in civilization, I think we're at a 1 in 4 chance of that. To look at the politics of what's going on, I mean, you might ask yourself, well, if things are that bad, why don't we do something about it? Here's a view from the Pacific Rim. So over on the right of this diagram, you've got the US. It contains about 5% of humanity. It is deeply, deeply creative and innovative. And I have put there a string of some of its major digital companies. I'm sure you know most of the names. In case you don't, NVIDIA up the top there is a chip company. Adobe is a software company. And coming further down, if you've got children, you will certainly know that Roblox is a game company. America it doesn't have a very high population density. It's got every resource that you could possibly want, and yet it is in deep trouble at the moment. It is deeply divided. Its own commentators express profound concerns about whether American democracy will survive this decade, and if it doesn't survive, what might happen. Possibilities being autocracy or some sort of prolonged civil disobedience or whatever. If American democracy doesn't survive this decade, the world will be, in my view, in a great deal of trouble. Moving to the left, we have China. China sits in a much, much more complex environment than the US. The circle I've put there contains something like 50% of humanity. It also contains, as it happens, 50% of carbon emissions. China is deeply innovative, deeply entrepreneurial, and I've listed some of the Chinese digital companies up there. I'm sure you know most of the names. Just coming down the column, I'll mention 2 or 3. Ping An is an insurance company, one of the world's largest insurance companies. CATL is the world's largest electric battery company. BYD is the world's largest electric vehicle company by number of units sold. And LONGi is the world's largest solar panel company. Now, if you look at the digital companies, Tencent, Alibaba, ByteDance, and Ant, the thing that is quite striking is how much smaller they are than the American digital companies. This is something which has changed dramatically in the last 2 years. 2 years ago, they were much closer in value, and this gap that's opened up is a reflection of Xi's policies of, in some cases, attacking and in other cases, constraining China's digital companies. Let me just move to the left, to Europe. So 2 things to say about Europe. It is now the main hope for the preservation of democracy, in my view. I mean, China is obviously an autocracy. America could be heading that way. Russia is deeply autocratic. So Europe is the defender of democratic values. Sadly, Europe is not nearly as innovative and creative as either China or the US. And I've put a cluster, I guess, of European digital companies. They are nowhere near as impressive as those in the US and China. Just to conclude on this slide, at the bottom in the middle, there's a pie chart of expected share of GDP by 2050, which shows China way ahead of everybody else. Not quite, but almost twice the size of the US by 2050. Lastly, I've also got on the diagram some little sunbursts. These are quite interesting. These are places where there are projects to obtain hydrogen, either from wind and solar or from the conversion of methane. They are springing up around the world, as you can see, Australia, the Middle East, and up in the North Sea. And then finally, I've put some green arrows on here. And these are migration paths. I refer back to my estimate of 1 billion people possibly wanting to migrate. And this gives you an indication of where the migration will happen. Over in the US, it's such a big place, it's unlikely that there will be more than internal migration in the US, but if the need arose, Canada is very much a wide open space. So the US is in a very strong position if migration is needed. China is in a much worse position. China will be very badly affected by climate change. Its northeastern border is pretty porous. There are plenty of Han Chinese living north of the border, and there is the obvious path for China. It's up into Siberia. Over on the left, there will be a large pressure of migration into Europe, and Europe has nowhere to go. It isn't at all surprising, in my view, that as far as attitudes to climate change go, the US is at least half of the US is not overly concerned about climate change. China is concerned about it, but it can see the way forward, and the Europeans are doing the most in the world to try and reduce emissions. When you look at this diagram, I haven't talked about Russia, but we all know about Russia. When you look at this diagram, you begin to understand why it is so difficult for countries to come together to agree on emissions reductions. The one thing all these countries have in common is that their citizens will not give up current income and current prospects in order to defray the damage that is going to come in 2030 or many years' time. So that's one thing they have in common. The thing that they have, they each also come from quite different geographical and economic positions. It's no surprise at all that little progress is made at the COPs. So that's all the bad news. The good news, there is plenty of good news, actually. So clean tech is going to take off exponentially fast. It is taking off exponentially fast. The top line here of pictures you know all about, I mean, renewables, my guess is there'll be something like 20% or less, maybe a lot less of the cost of gas-fired generation by the end of this decade. Grid-scale batteries that you need to stabilize the grid over the short term will be competitive with gas generation by the end of this decade, is what I guess. Hydrogen is, you saw the number of projects coming on stream. Hydrogen is very expensive compared to gas generation, which I take as my marker. But by the end of the decade, it will be catching up with gas generation. I think there is just so much investment being poured into it. You need smart grids to balance supply and demand, and ideally continental scale smart grids so that you can take power from right across a very large region. The reason why renewables don't take off as quickly as you might expect, given the marginal price advantage, is the system you need to operate them is quite complicated. It's got all of those things in them. The reason you need hydrogen if you're in the north is that the wind doesn't blow and the sun doesn't shine maybe for a month or two at a time in the winter. So you've got to be able to back up the grid with 2 months energy supply. Hydrogen is the non-carbon way of doing that. You just store it in a salt mine. Over on the right, I've put a picture of the Rivian pickup truck. Rivian IPO'd just before Christmas with a market value of about $100 billion, having made in its lifetime 1,000 vehicles. It just shows you how quickly the market is expecting electric vehicles to take off. I mean, exponentially fast over the next few years. Now, that's, if you like, clean tech 1.0. Clean tech 2.0 is in the second row. The steak on the bottom left is a Wagyu beef steak, but it's never seen a cow's backside. It was digitally printed by the equipment you see above it. The digital printer used for ink, protein cells and fat cells and blood cells. I think that the most important development on this chart after renewables is that if you can make high quality beef digitally, not digitally, if you can make high quality beef in a factory rather than in a field, you've got a 1 trillion per annum market to go for. If you could capture that 1 trillion market and displace 4-legged cows, you could do 2 things. You could eliminate the bulk of emissions from agriculture, and you could reforest or rewild, whatever you want to do, the bulk of agricultural land. That printed steak could solve the climate problem if it can be got to market quickly enough. Its next door neighbor is protein-based flour. The flour was made out of protein made by a bug in a vat. The bug likes eating carbon dioxide and hydrogen. The pancake made with flour tasted pretty good. That's a 300 million market to go for and would replace wheat crops. And finally, its neighbor is a cup of coffee. The coffee was made by growing coffee cells in a vat. If you can grow coffee that way, you don't need to cut down rainforest to grow coffee agriculturally. My view of the world is that agriculture could and should be replaced over the next couple of decades if these products can be got to market fast enough. Then we go on to carbon disposal. That big rack of fans sucks in carbon dioxide, pushes it through a solvent. When the solvent is saturated, you heat the solvent up and bubble out pure carbon dioxide, and then you can dispose of it. One way of disposing of it, which has been topical recently, is in Iceland. Iceland is a giant basalt rock. If you if you dissolve carbon dioxide in water and pump the water down into the basalt, it crystallizes, the carbon dioxide crystallizes into calcium carbonate, it turns itself into rock, and is safely stored forever. The cost of the storage part of what I've just said, cost of shipping carbon dioxide to Iceland and storing it there is about $10 a ton, something like that. The cost of capturing carbon dioxide from a smokestack where it's highly concentrated is about $30 a ton. You can do an all-in carbon disposal for $50 a ton from a smokestack. This compares with an EU carbon price of $100 a ton. There is a carbon disposal industry about to take off. If you want to capture carbon from the air, the economics are different. It's probably a $600 per ton carbon disposal. So it's going to be a while before the carbon price and the cost of direct carbon disposal from the air line up, but that will also come in the 2030s. The last thing I want to talk to you about is talcum powder boxes. There are two on the right there. They're made of plastic. The plastic wasn't made from oil. It was made from wood chippings. And that's by way of saying, it was made from wood chippings and is biodegradable when it is thrown away. That's by way of introducing the subject of digital chemistry. There have been remarkable developments using AI. If you want a molecule or a material with some specific property you have in mind, you can now use an AI algorithm to design the molecule, an AI algorithm to design a recipe to create the molecule. There are now robotic synthesizers that will take the recipe and make you a sample of it. And if the recipe is successful, it can be filed on a database so other people can use it. Coming pretty soon will be the ability to simulate the material that you're dreaming of before it's even made using quantum simulation. My guess is that the rate at which new materials will be invented will increase astronomically fast during the course of this decade, so that all the stuff that we make and use which is harmful to nature can be replaced bit by bit. I should have mentioned, or I should have had a picture here of for modular nuclear and for nuclear fusion. I didn't have room to put them on, but there are also quite big advances taking place there, all of which are pretty optimistic things. What will it mean? It will mean the following on a, shall we say, a 15-year timescale. Coal will be uneconomic and will go. Methane, ditto. Petrol cars, ditto. Oil-based plastics will be replaced. Oil, depending on what the producers do, oil will trade in a range of $25 to $100 a barrel. $25 if the producers don't see what's happening and continue investing and therefore overproduce as demand falls. $100 if they cut back their investment and match supply to demand. Either way, the petrostates are going to be depressed as demand falls and possibly price falls as well. Ranching, if we can just, if synthetic meat can capture a large chunk of the market, ranching will go, and I think the agribusiness is going to be transformed, all on a scale, in my view, of 15 or so years. Obviously, this means that clean tech's value will surge. I have put there some sectors of the clean tech industry, and I've color-coded them so that you can see where North America supplies things. That's the light blue. Where China does, that's the pink. Where Europe does, that's the yellow. And where other Far Eastern companies supply, that's the dark blue companies, dark blue squares. What can you pick up from this? Well, what you pick up from this is that in solar, batteries, and electric vehicles, apart from the one dominant US company, which is Tesla, of course, this is very much Chinese-led market. Wind turbines, Chinese competes on an equal footing with Europe and the US. Over on the over to the right of the table, the new stuff that's coming: hydrogen, clean meat, carbon disposal, quantum computing, and nuclear. China is not yet in the forefront, but my guess is it will be moving that way quite quickly as these things take off. Just to finish on China, there's a diagram there of China's energy mix. The blue is 2025, the orangey color is 2060. You will see how China's energy mix is going to go from coal to equal amounts of wind, nuclear, and solar. That is a blueprint. That's a blueprint, I think, for many, many countries. China will make its energy transition when China decides it can. It certainly wants to, but as my little box on the right says, it has 2.5 million coal employees, all located, I think, in one northern province. There are profound social issues that have to be addressed. So, to summarize, we're in the early Anthropocene, and it's going to be tough. What we have going on is an anarchic, chaotic, super transition. It's well underway. The elements of it are what I've put in my little diagram there: climate change, nature destruction, changes in energy systems, food systems, transport systems, and materials, the potential for lots of migration, mainly possibly a sharp drop in population. If sperm counts don't recover, maybe a sharp reduction in economic growth or in economic output. We have the rise of China and the rise of AI. Huge amount happening. I've called it anarchic because no one is in charge. It's quite a realization that no one's in charge of this amazingly fast change. The change I've said is amazingly fast. Of course, it is in geological time. It's almost instantaneous, but it's slow in news cycle time, which is why people's attention waxes and wanes. The COPs, conferences of parties, have tried to deal with some of these changes. What they can do is cajole and encourage, but they can't prescribe because no one is in charge. It seems to me that a 2C plus, more than 2C of warming, dangerous, degraded world is now all but unavoidable. How bad it gets is I think, still up to us. But what is clear is systemic risk is increasing and will increase. Resilience will be valued. Long-term economic growth and social stability are certainly not givens anymore. And in the immediate future, a big concern that the US may fracture. Perhaps more positively, there's likely to be a multi-decadal digital and clean tech investment boom, exponentially fast innovation and scaling up. The scaling up will be exponentially fast because governments will push like crazy to deal with these problems. Multiple transitions, of course, as I've said, and multiple disruptions of energy, food supply chains and infrastructure. Eventually, I think there's going to be a property bust, and I think there's going to be a property bust because lots of property has been developed over the last decade in desirable locations, which are also the locations which are most vulnerable to climate change, whether it's rising, whether it's fires or inundations. The reason I spend time on this is the very last point in my box on the left. Small leveraged events and actions may have large future impacts. We, people who are interested in this, can act together to reduce emissions and preserve nature and reduce the AI risk. And we can do this because it's a chaotic transition, so small changes can have large impacts. I'm working with China, helping them apply their environmental laws and bring legal cases onto their environmental laws. And we got on very well with them. We were very helpful. And off our own bat, we wrote a memorandum, 2-page memorandum about 3 years ago, saying why the Belt and Road Initiative investing in coal plants was a very bad idea. And I mean, what we simply said was it was a very bad idea because they would lose a boatload of money. 2 or 3 years, that memorandum worked its way up the chain of command and worked its way back down again. And lots of advice was taken from lots of other people. And eventually, the result was that China announced last year that they were not going to finance coal plants in the Belt and Road Initiative. And you will see on the Chinese Ministry of Environment's website a thank you to Client Earth for its help in this matter. So, I mean, a very heartwarming example of what small groups of people can do in these chaotic times to try and make things better. And I'm going to stop there. Thank you.
Thank you so much, Howard. Second time for me, and it still has the same effect. So I hope that everyone here enjoyed the presentation. There's a couple of questions that have started coming in the chat, and I'll get to them. The main feeling that I have when I listen to this, Howard, is that I'm overwhelmed. I'm overwhelmed, right? And I think about when you talk about no one being in charge and the anarchic and chaotic nature of this, I also think about all the cognitive dissonance that we all go through accepting the reality of the facts of the changes that you're describing on the environmental front, on the technology front, and otherwise. It's reassuring to see some level of technological opportunity and optimism, and I'm very glad for this. At the same time, it's interesting that the risks you highlight, the bigger risks to humanity, are elsewhere. You know, they're about American democracy. They're about AI domination. My words. They're about you talk quite a bit about migration patterns. We've been doing work on the border surveillance industry. That's going to be one hell of a disruption. And the other one that I think is between the lines, but really interesting, is the supply chain bifurcation. Right? I mean, you talk about China's position and the US's position and the sort of Cold War in between, and investors are already taking bets on which way, and how the supply chains are going to go. And it'll be really interesting to see how that will impact each bloc's and people outside of the bloc's ability to implement technological solutions to access the natural resources, the rare earth minerals and other things that are needed for these technologies, and so on. So 1 chance in 4 of technological of significant or deep global disruption. Yeah, wow. So that wasn't a question, but I want to go to the ones in the chat. Carolyn, you talked about what should we do to reduce AI risk? Is it about ethical standards for algorithmic development, for example? What do you think, Howard? What can we do, and what can investors do?
Okay, so the answer to that is a very complicated one. First of all, as the AI experts, ethical experts have sat down and discussed precisely this question, there is the obvious realization that ethics is by no means straightforward. It's very, very complicated indeed. And when you start thinking about ethics in terms of what computer code you would write to make an AI ethical, it becomes unbelievably complicated. So you have to solve the problem of how you get AI algorithms to align with what humans want and not to have their own non-human objectives. And that's a highly complex technical problem which is being worked on. As the solutions are found, it will then be necessary to sign all AI institutions and companies up to some sort of code of conduct that makes the algorithms, if I can put it this way, subservient human desires and not independent algorithms. There's a long way to go on that, but there is good work going on.
Very good. And I will share, I was trying to juggle here, a very interesting article that our friends at Ethical Systems published also about what it means to put AI or to have artificial intelligence in the service of humans, knowing that our own perspectives and morals and values change over time. So how do we do that? There is a string of questions from Bill. I'm going to try to summarize here. Bill, you talk about the upcoming adverse tipping points on maybe I focus on the second question. The adverse tipping points and thresholds on the environmental and social side, and then the role of markets. And then the question you ask is, well, given these tipping points, what does it mean for the supply, the supply chains, for example, of hard metals that are needed to make all these new technologies come to life, right? Is that a fair summary?
Sure. That gets okay. Part of the question. Yeah.
So, I mean, supply chains is a deeply interesting problem, of course. I mean, first of all, Jerome, as you said, supply chains are, well, the world is splitting down the middle along north-south down the Pacific Ocean, with China on the one side and the US on the other. And I mean, as far as one can see, that is something that is just going to go on. I think China is going to become more authoritarian, may even become totalitarian, and more difficult to deal with. And what happens in the US is anybody's guess. But people other than the US and China are going to have to adapt their supply chains to that political system, and they're going to have to adapt their supply chains to what may happen in terms of climate change. It's no easy business, and it's going to be a continual process of adjustment over the next few decades, almost.
Thank you. A question from Ollie Kians from Schroders. Thanks for joining, Ollie. Similar to no one is in charge, how important are the global commons that lie beyond jurisdictional boundaries, i.e. the high seas, Antarctica, outer space, and holding solutions, but also being some of the most impacted but not owned areas?
Of course, the global commons are fundamentally important, and to look after the global commons, to care for the global commons, you do need agreements between the parties, and then you need to enforce those agreements. And I mean, it's quite interesting. Nobody is in charge, but in areas, little bit by little bit, you can move things forward. And I think that the game that all of us who are concerned about the environment and about the Anthropocene, the thing that all of us can do is try and pick areas and move things forward and make things better in areas. So I think that the global commons is certainly one where agreements can be sought. But I mean, the Arctic is a fabulous one. I mean, China's got a position there, Russia's got a position there, the US and Canada have got positions there. Their interests certainly do not align.
That's encouraging. Please keep firing questions in the chat. We have a few more minutes. Tom, at the beginning, you asked, sorry, I jumped right over it. Where are we? What specifically do you, Howard, envision as being the small leverage actions group can take to address many of the very salient risks you have described? So you talked about this a little bit, but right now, if you had a magic stick and got control of all the anarchy, what would you ask to happen?
So I think what's happening in the financial markets is deeply interesting. I think Mark Carney's initiative. So, I mean, there's an example of one individual who's a very prominent, high-profile individual, bringing about some, I think, quite significant change. So harnessing, if one could get the bond market behind environmental protection, then one would have achieved a great deal. And I don't know about the bond market, but I think you can push banks in that direction. So between the kind of initiative of Mark Carney, Client Earth, which I know about, is being very assertive, shall I say, with a number of banks and their activities, both in financing fossil fuels and in not looking after the environment. I think pushing the economy in the right direction by addressing individual companies and individual institutions one by one is something that groups of individuals can certainly do.
So relentlessness as opposed to a grand strategy.
I think it has to be opportunistic. It has to be relentless. You have to have your eyes on the technology, because if you take companies to a court, a judge will not ban something that people want unless there is a substitute readily available. So you can't get a diesel ban until electric cars are in the offing, for example. But once the technology is coming through, I think the courts are more than open to taking steps to ban harmful practices. So the combination of individuals acting and technology coming through very rapidly leaves me sort of modestly optimistic about our ability to stop super catastrophic change. I do think we're going to get, I mean, life is not going to be easy, but we can stop it getting desperately hard, is what I think.
Fair enough. On the point of technology, so there's a question from Martin Smith in the chat about the role of nuclear fusion in the future energy mix. But I also want to go back to with this to the different substitution technologies that you described in one of your slides. And my question with that is, do you think that financial markets are doing enough to get these substitution technologies in place? And should we then just leave markets to do what they're doing and focus on the other hard stuff?
So to answer Martin's question on fusion, I'm very encouraged that there is now a $1 billion fusion startup. There is a fusion unicorn. If the folks in Silicon Valley think fusion is going to make progress quite quickly, that is good enough for me. I will back that. I mean, obviously, modular nuclear fission is, I think, moving along quite quickly. One can hope that fusion will come quickly enough to make a difference to the problem. I think the chances are that it will right now, but I mean, it's not around the corner, but it may be a decade away now. Sorry, Jerome, you asked me.
I was asking whether financial markets are doing what they should be doing in bringing new technologies online.
So the financial markets have a time scale. They have a forward time scale of about half an hour at worst and about a week at best, in my view. I mean, Raj and I started talking about this stuff, God knows how long ago, I don't know, 10 years ago. And the financial, all the investors and the banks we talked to just laughed at us. They thought we were crazy talking about climate change and the destruction of nature. They had no forward view at all. So they've caught up now with where Raj and I were 10 years ago. And of course, the scientists were there 20 years before that. So I think the financial market's probably 30 years behind what's really happening. And they're 30 years behind because all of their incentives are to make profits this quarter and forget about the future. They're being forced to think a bit about the future, but they're doing nowhere near enough given the severity of the threat.
Fair enough. And so we'll keep pushing them. I'm going to take a last question because we're past the hour and I don't want to take up too much of people's time. Jyoti, hello Jyoti, Happy New Year. You asked, I get the impression that risk managers think about risk to their entity and then seek to come up with actions that can carry out which reduce these risks. But doing so in the context of systemic risk is like bailing water out of your own cabin on the Titanic. And so do we need new skills and approaches in risk management?
Well, that's interesting. I mean, so you sell your coal shares to private equity who boost the carbon dioxide emissions after they've bought them. So what does that do for systemic risk? Well, it makes it worse, of course. So your point is absolutely well made. I think so. So resilience is going to be the watchword, at least for the next decade or 2 decades. So encouraging, I mean, looking for resilient investments is the thing to do, and avoiding investments which are going to suffer as a whole host of unexpected by most, but I mean clearly coming, a whole host of events come along and disrupt things. I think there will be a premium for resilience. I don't think the financial markets are anywhere near aware of that yet, and they won't be aware of it, of course, until after the first few disasters, and then it will be clear that there's a resilience premium. So I guess preparing oneself for resilience and to invest in a resilient way is the thing to be thinking about.
Thanks so much, Howard. So we'll bring this to a close, and thank you, Howard, for taking the time for putting together some very compelling data from both the technology and the environmental space, but also the sort of social systems around them or at the center of them that really, I think, capture something fundamental about the present moment and the risks in the next decades or decades. It's always food for thought. One question that I have, and I keep going back to, and that maybe I can share with the audience for, like, not quite homework, but just something to think about if you think it's interesting, is, having listened to this, how does this affect how you think, and how might this affect how you do your day job in the near future? Does it give you a new insight, or new drivers, or maybe new motivation? Certainly does for me. Thanks for joining. Please, let's stay in touch. Let's all be friends, and we're all in this together. And I look forward to I don't know, a wonderful year of social change in one form or another.